First of all, just going to give a quick intro to SSE. Airtricity is now part of SSE. Airtricity was purchased about 1.5 years ago. SSE is the second largest electricity and gas network owner in the UK, about 9 million customers and over 11,000 megawatts of installed generation capacity. About 2,200 of that is renewable, so that's wind and primarily hydro. Can you hear me? No? Okay. And 400 megawatts of the installed capacity of the renewable capacity is in Ireland.
Can everybody hear now? Is that okay?
Is the microphone switched on? Turn off the microphone. Somebody is.
Okay, is the mic on or off?
It's
on. Now it's off, but
it should be a blue light.
Yeah, the blue light's on, yeah.
Turn it to one side and stand at the side of the room.
Okay, just try.
Okay, we'll do what we have to do here.
Can everybody hear now? No?
Well, if I talk, you might actually hear me, that might happen. Okay.
Freestanding mic here. Oh, yeah.
Better? Yes? No?
Yeah.
Okay, hey, listen, that's better at this stage. Okay, so some of the key questions that have been posed to SSE, basically, and these are questions that are not just for the likes of any company, but they're also questions that are relevant for any country at the moment. So how to respond to climate change? One of the main things we have to do is drastically reduce the carbon intensity of the electricity that's being produced. And one of the main targets that we're facing at the moment is the 2020 target. How do we address the dilemma of rising global demand for energy with depleting oil and gas supplies? And again, it's to start really focusing and concentrating on renewables and building large portfolios of wind, hydro, marine, solar and biomass, and I think that's all of what is being discussed here today, and it's extremely relevant in the European context at the moment. How do we secure energy supplies and make them more reliable? First, it's focusing on a European platform, not so much looking abroad at the moment. Our customer base is in the UK and in Ireland, so for us it's really going to be about focusing on the European platform and also building local, sustainable energy sources. And a key part of that is going to be offshore. Just to put that in context, the investment that SC is going to make over the next 5 years, between 2003 and 2008, 3.4 billion was spent, and 19% of that was on renewables, so whatever that is, 500 or 600 million. It's going to be close to about 4 billion between 2008 and 2013, so it's an absolutely massive spend. Around another 2,000 megawatts or so are going to be put into either the ground or the sea. So then if we look at the Ireland situation, currently ESB is looking and expecting to install or have connected up about 6,000 megawatts of wind plant onto the system by 2020. And then there's maybe expectations of a further 6,000 megawatts going beyond that, which would be past gate 3. There's a whole process at the moment of gating of wind farms onto the grid. It's not a simple process where you've got a wind farm, you just come along and you just connect it onto the grid. There's a whole system of queuing. You have to get your planning permission, but then there's a queue system for the grid. And grid is one of the key issues that we're facing. Of the 6,000, about 750 megawatts of that is offshore. This will also equate to around 16.5 terawatt hours of energy from renewables. Just putting this slide up because it gives an idea of the scale of what's happening offshore. Now, Ireland has not been very great as far as what's happening in the offshore arena. We have the Arklow project. It's about 200 turbines which are currently consented to be built off the east coast of Ireland. Another number of developments are ongoing, again mostly on the east coast. Either organisations have acquired the planning consents or they've acquired the grid, but it's been very difficult to actually get the two of them to line up. Even if we were to get the two of them to line up, what you find is that the economic situation doesn't really support a lot of offshore wind in Ireland. But I think what's very notable, right down at the end, you can see UK, 33,000 megawatts is the expected offshore construction programme in the UK between now and 2020. It's an absolutely enormous programme. Talking about ARCO again, what you see up there on top is a photomontage of ARCO if we were to build out 200 turbines. What we're looking at today is a solution which may look towards developing ARCO, however connecting it mostly into the UK system. This is something that we may be faced with. Instead of actually using this energy and pumping it into the Irish system, we may find ourselves actually pumping it into the UK system. And then at a later time, when the nodes and whatever else developed in this country to allow that kind of quantity of renewable energy from one location into the system, then we may be able to also run into ARCO. Now, why I've put up this slide here, this is offshore in the UK, and I'm saying is this an opportunity for Ireland? If you look at the way the UK is run, it's a programme of rounds, as they call it, so rounds 1, 2 and 3. Round 3 is the current one at the moment. Round 1 happened a number of years ago, and it was heavily funded, and well, not so much funded as grant aided by the UK government. The UK government has put an awful lot of money into R&D. Various different organisations are currently responsible for looking at all the different aspects of deploying large quantities of wind, primarily offshore wind, onto the UK system. Round 1 is 1,500 megawatts, round 2 around 7,000 megawatts, and round 3 up to 35,000 megawatts. Some of this will be as far as 200 kilometres offshore, and some of it will be in water depths as deep as 60 metres. On the west coast, which I think is quite important for the Irish context, if you look at the light blue coloured areas there, those areas are the round 3 locations. And if you can see that some of them are basically the same size as a county in Ireland. So the scale of these developments is going to be enormous. It's probably around 12,000 megawatts or so, which is going to be along the west coast of the UK. So the main challenges in actually deploying this quantity of wind are cost, design, reliability, and integration of large volumes of variable megawatt hours onto the system. So within SSE, as you can see, the scale of what we're doing is absolutely massive. It's going to be probably larger than what Ireland as a country is doing. And these are the areas where we're putting a lot of our focus. So on the cost side, one of the main issues we've got is supply chain. Increasing the supply chain is fundamentally important. There is just a lack of supply chain currently, and with the lack of supply chain, you get cost increases. So we need greater competition. There's an awful lot of opportunities for companies, whether they're in the UK, in Europe, or in Ireland, to actually get involved in this space. There's still just general lack of competition, but also just lack of skilled human resources and other resources in this industry. One of the main areas we're seeing it is in the wind installation and owning vessels. That's where there's key issues really. Then if we look in the design area, health and safety, you wonder what's that up there for, but we find that an awful lot of issues are happening on the health and safety side that really could be avoided. Some of them are avoidable, and some of them are causing actually, say, reductions in revenue, you might say. For example, one of them, if you're trying to, in offshore wind in particular, if you're trying to actually access turbines that are out in the sea, one of the main issues we face is you're just trying to get from a vessel that might have carried you over to a turbine, and actually try and get off that vessel and get onto the turbine in order to carry out whatever repair works need to be done. There are limitations on wave heights, so if the waves are too high, you simply cannot get out onto the turbines. And it might seem like a big thing, but this could go on for days and days if there's a storm or whatever. So these kinds of things really require that the turbine technology is looked at. We're looking now at the turbines today around the 3.6 megawatt, the type of technology that's out there.